Good day, everyone. This is Chris again. I'd like to discuss something a little more on the lines of chemistry, like pretty much like I always do. But I'm actually going to discuss this in response to a question somebody asked me. Was last week I was actually helping teach a paramedic class, and one of the students from another one of the classes is in the process of writing a paper on the concept of precipitation. Specifically in medicine, there is this concept that occurs that if I mix two medications in a syringe, depending on whether those medications are compatible or incompatible, I can have certain reactions. And if they're incompatible medications, there is a precipitation that develops. And he was just wanting to know kind of what happens there. What are the underlying concepts that kind of lead to the development of this precipitation? So I'm just going to kind of talk about this maybe in a couple of lectures. So the first question we have to ask ourselves before we look at the concept of what a precipitation is and a reaction and all that is, well, what does it mean to have something dissolved? I think that's probably where we want to start. What does it mean to actually dissolve a substance? Well, what it means is obviously that there is some sort of chemistry involved that leads to this concept of being dissolved. And let me try to give you a more of an intuitive sense of what it means to dissolve something. And I'll do that with something that we all know, or we should all know fairly well. So what I'm going to do is I'm just going to draw a container here and imagine that we're, in a general chemistry lab and we're doing some experiments, and I have a little container, and we know that a solvent is something that solute is dissolved in. So if I take a sugar cube and drop it in a little tub of water here and mix it up, I can dissolve that sugar, and of course the water becomes a solvent and the sugar becomes a solute. Now there are certainly other kinds of solvents, but what I'm going to do is I'm going to stick with the one that is very common in biological systems, and that is water. Well, let's talk about a water molecule. You look at its molecular structure, it's H2O, I have two hydrogens and an oxygen. But that doesn't really tell us much specifically about the chemistry of this, about the electron. What's going on with the electron? Because we know that most of chemistry is because of an electron or electron interactions. Well, what we know is, we know that we have oxygen, okay? And we know that oxygen has a property known as electronegativity. And what electronegativity basically means, and perhaps I could even do some videos on periodic trends a little later on and talk about how we find this out. What electronegativity is this an atom's, not affinity, that's actually something a little different, but basically an electronegative atom is hungry for electrons. It really wants to get a hold of an electron. And oxygen is very electronegative. It really wants to get a hold of some electrons or an electron. That's, in a nutshell, what electronegativity is. And we know that nonmetals, like oxygen, are generally more electronegative, and metals, like sodium and potassium, are not as electronegative, and they easily give up electrons. And that kind of makes sense when you think about ionic bonding and so on. Okay, so we know that oxygen is really electronegative. It likes to pull onto those electrons. Well, what we have in the case of a water molecule is I have oxygen and I have two hydrogens. And hydrogen is not as electronegative as oxygen. So we know that hydrogen has a valence, one electron. And what do we know about oxygen? Well, we know that oxygen has not met its octet rule. And if you remember from organic chemistry, they talk about HONC and how many bonds can form to meet the octet. Hydrogen's 1 bond, oxygen's 2 bonds, nitrogen 3, carbon 4. And perhaps I can even just do a basic chemistry discussion about some of the basic concepts. So oxygen needs 2 bonds to meet its octet rule. So what do I have? I can have 2 single covalent bonds here where I have sharing of electrons. Okay. So there we go. Oxygen's met its octet rule, but is it necessarily happy chemically? And the answer is no, because it's still electronegative. So what it's going to do is it is going to pull on those electrons. So yes, there's a sharing of electron to make this bond, but it's certainly not equal sharing, and the oxygen is pulling the electron, tugging on it more strongly, so the electron spends more of its time around oxygen. And what that does is that creates what we call the dipole, where oxygen is actually partially negative because there's the electron is spending more time there, and the hydrogen becomes partially positive. Okay. Now what happens when so this is how water is. This is a water molecule. That's why we call water molecules actually called polar, because it has this negative and partial positive pole. Well, what happens when I introduce an ionic compound like sodium chloride? Table salt. We know that table salt is generally a solid, and its sodium loses an electron, becomes positively charged. Chlorine gains that electron and becomes negatively charged, and then the interaction, the Coulomb interaction, causes the positive sodium and the negative chlorine to come together to interact through that Coulomb's force, the Coulomb force. Well, what happens is if I take this salt, this solid, and I put it into an aqueous solution, water solution, what's going to happen? The sodium is going to be attracted to the oxygen. The chlorine is going to be attracted to the hydrogen. And we're actually going to pull this apart. This ionic bond, this molecule will be pulled apart, and the sodium will be attracted to the oxygen here. So here's my sodium. It's attracted to the oxygen, whereas the chlorine is going to be attracted to the hydrogen. I'll have the chlorine here. So I pull that molecule apart, and that's actually how stuff dissolves in water, is it's through the electrical interaction, because water is a polar molecule. That also should explain why certain substances such as lipids and fats and fatty acids generally aren't as soluble in water, because we know a lot of those lipids and acids are not polar. They don't have a charge to them really, so they don't interact with this water molecule as much. Okay, so we now have a working understanding of what it means to dissolve something in water, or an aqueous solution. I think in the next video I'll talk about what it means to cause a precipitation reaction. Thanks, guys.